Okay, can you guys hear me now? Oh, okay. Yeah, I had the cable disconnected. The chat isn't working. Okay, so let's try to fix that. As always, I mean, this is my intro. Let's see. Okay, it's working now. How are you guys doing? We'll wait for some more people to join. I hope I'm not lagging because my connection isn't quite stable today for some reason. But the bitrates should be okay. Well, yeah, I think we can start now. People joined. Um, so today I asked on the Discord server what should I do in today's stream, and they decide to watch some compiler development, and so we are continuing on the project from the last video, the C compiler. But since that video was like um, 10 minutes or so, I will first explain how it's structured, because I streamed the process of making that compiler, but I was on Twitch. I have 12 followers there, and so probably no one really watched that. So okay, we can start. Hello everyone. Yeah, I don't really remember uh, what I had. Like I remember. Yeah, okay. So here I encoded some C code. So let's see. Okay, it produced me this assembly here, and we should be able to compile this. Oh, right. What? Hmm? Okay. Hello. Uh, about new cloud model. Okay, so I think that in general, programming is moving towards cloud applications and web development, and that's like a state of fact, I would say. But still, we have to remember that without low-level programmers, that stuff doesn't really exist, because the entire web runs on basically most of the web runs on the V8 JavaScript engine, which is very, very, very low-level stuff. It has just-in-time compiler, so it's not like they are gonna replace low-level programming. And also, I think that low-level programmers will be the last one being replaced by AI. Because from what I've seen, if you ask ChatGPT and friends to produce some like web content, they can do that mostly. But when you ask them to do some embedded stuff like x86 paging or similar, they really can't handle that. And of course, it's probably because it's less less documented on the internet, so they are trained. They can also render it. You mean websites? So yeah, since low-level programming is less documented, probably artificial intelligence are less trained on this kind of stuff. Huh. Okay. Okay. Um, so it's nice to see that I got a segmentation fault just by trying running this thing here. And yeah, that's curious. So I would like to know why. That's because here, where is it? Yeah, here I was writing 2 lines, but that shouldn't really be a problem. So what's going on here? Um, let's see. Oh wait, how long is this string? Yeah, the number should be correct. Okay, so let's see. Mm, I've been using Zig for the past 6 days, so now coming back to C is amazing. Okay, so here I have to wanted to say this. What's going on here? Okay. Well, there shouldn't really be a reason for this not to work. Hmm. No, I'm using make. Very simple make file. So let's see. Okay. Okay, that's something. And I think that um, the segmentation fault is because I'm not calling exit. Your stream restarting too much. Uh, you mean it's lagging? Are there connection problems? It's fine. Okay. So I need the exit syscall. Exit. Okay. Which is 60. So where is it? Exit. Okay. So we have rugs, right? Yeah, array X. Syscall. Let's see. Okay, no more segmentation fault. So let's fix that real quick, because let me explain. So I was generating this binary here, this assembly code, which has some issues. So here I was passing 13 characters as a length, but this is 14 because there is also the leading 0 here, the null terminating character. And that was one problem. And the other problem is that I was getting a segmentation fault because in Linux you have to exit, to call the exit syscall when you finish running the program, because if you don't do that, the program will try to run the next memory address after the code ends, and that probably isn't going to be some correct instruction, so it will just segmentation fault and crash. So you need to call the exit syscall, which is the call 60, and then you have to pass the return code. So this will be 0 RDI, and then you do syscall like this. So if now I compile this assembly, everything works. That's it. So that's a problem in the code gen. Can I do something like this? I don't think so. Let's see. What about this? Oh. Okay. This is interesting. Yeah, okay. Didn't know this. So that's even simpler. Yeah, okay. So now I just need to parse a return. But what will 13? Okay. So 13 was in RDX, so I guess the return code is in RDX. Let's see, I will put 5 here. Oh, I haven't compiled. Okay, and let's see the output. No, it's still 13. It's still 14. Okay. Oh, that's curious. So let's see. Writing C compiler. That will probably be hard. I don't remember in x86 assembly the return code. Where does it go? ArrayX. Okay, yeah. Yeah, that's probably too hardcore. Let's stick with C. Okay, so I have to implement the return expression. Just that. And I really haven't touched this code in a long time, so I don't remember if I have the return thing being parsed. And it looks like I don't. Okay. Hello Marco. Well, did I vanish? I was streaming almost every day. What software do I use for my thumbnails? Nothing. My thumbnails are whatever YouTube gives me. Really random thumbnails. Okay, so in the keywords here, we also need return. Okay, and I will add that here. Okay, and now here I also have to parse the return statement. So let's see, where is the statement code? Here, okay. Okay, so here I was directly checking for an identifier. But now I need to check also for the return instruction. Oh yeah, on the first video I just used GIMP. Nothing fancy. Okay, so if check, let's use check consume return, then I will just return. Oh no. Okay, this is the function code. I wanted to see if you were keeping attention, of course. Where is it? Okay, here it is. Stream works again. Okay. Well, this is really simple, I have to say. So parser.h, and here, where is it? I just have to add return. Okay. And then here I will add okay, and I have AST node T value. Okay, hello everyone. Oh, we don't have hell tonight? Well, this will be the first live he will miss. Okay. So in this case, we will return, of course, list. Oh. Why are your functions? That's the uh, that's the K and R convention. That's the K and R convention. Okay. Yeah, I can explain the files. I briefly explained that already on my video. So if you want a brief explanation, go check that out. It's 10 minutes. But anyway, the first stage, it's the lexer, where I get the input as a string, the source code directly. And then I check for the special characters. I will change this. I will use computed gotos. You will see. If you don't know that, it's very cool. So I check for every single character, and I translate the characters into enum entries, so to numbers. And then I do the same thing for numbers, number literals, and here for string literals. This is for compiler preprocessor, and this is for identifiers. So that's what the lexer do. It translates the string source code into a list of these enum entries. Then there is the parser. Oops. Oh, okay. We just the parser just takes the list of tokens from the lexer and uses an algorithm here which is called recursive dash parsing to generate a tree, which is the abstract syntax tree. Are you on Linux? Yes, I'm on Gen 2. And yeah, after the abstract syntax tree, you go to the code generation stage where it traverses all the tree and generates code from that. Calendar convention? No, it's the Kernighan-Ritchie convention. Calendar. Calendar, as you can see here. That's my style. Rather than your language compiler, because it's easier. C is very easy language. And also, I asked what I should have done today, and you guys said that I should keep going with the C compiler, so that's why. I hate you, I am an hater. Okay. I have no problems with that. Weird style, to be honest. Well, that's the original C style, because it's what's defined in the first C language book by its creators Kernighan and Ritchie. But yeah, most other languages use some different indentation style. What were we doing? Okay, the return thing. AST return. Okay. You're writing your own. Oh, okay. That's cool. That's cool. Yeah, since I'm creating an entire game using Vulkan and having a WASM runtime in Zig, now I think that after more than a week, I can finally do some C, and then I will go back to Zig. I have to define the return statement here. Is the return. Okay. So the return statement is pretty simple. We just have to get an expression. So here I've got the value. Okay, and I will check for an expression. Just this. So value value t equals to, oh god, I always, how is this not, yeah, this will conflict with the identifier. Yes, I'm using a union. Are you writing the compiler in C? Yes, I am. Yeah, I'm using a union for all the various statements. Ciao. Your name is very difficult to pronounce. Hello. Why aren't you using VS Code? I'm. I don't know how to reply to this because I use Vim. That's what I'm used to. No, there should be also. I always forget his name. Also, Lalo should be Italian. I used Emacs. You used Emacs or you use Emacs? Because I also used Emacs and really it was too complicated in my opinion. I don't need 90% of Emacs features. It's extremely inconvenient. For me, it's extremely convenient instead because once you get used to all the mappings, you can write way faster. Thank you, Ulce. Do you have a simpler name I can use? Uh, this code really needs some refactoring. Really needs some refactoring. Emacs binding is. I used Emacs with evil mode. The problem I have with Emacs bindings is that um, you have to use control a lot. Like I don't really. I think my hands would hurt a lot. Yeah, I really think most people use evil mode. I never met someone using the the vanilla Emacs bindings. Um, statement return value equals to AST expression. No? How is that called? Expression. Again, this thing really needs some refactoring. Really. Why aren't you right? Well, uh, I'm not using Microsoft Word, even if it's a very, very, very wonderful IDE, because sadly it outputs to some sort of XML format, and so the compiler can't really understand that. If they fix this bug of outputting XML, I will definitely use um, Microsoft Word instead of Vim. Way more convenient. Font, I don't know. I don't know, guys. I keep receiving questions about my font, my theme, my I don't know configuration, but this is whatever comes by default uh, with Gentoo when you install Xorg stuff. Okay, so the return statement should be already parsable. Is it? Let's see. So here I need to add a new line which will contain return free. Let's see. Um, CodeGen, no, not this one. CodeGen C. Okay. Also CodeGen H. Gen return. Okay. here. Okay, so yeah, statements in my compiler are, well, whatever doesn't have a value itself. So you have function assignment, sorry, variable assignment, variable declaration, function definition, function call, even though now that I think so, function calls are expressions because they have a return type, so they get a value. Okay. Okay, I need to change that. Thank you for pointing that out. And so yeah, basically that's the distinction, but really is something I feel. Okay, so how do I gen literal? Okay, so here I will gen move, and I have statement dot statement dot return value. Okay, oh, I also have to pass the file here, value, and then the register, which is RIX. Yep. And then I have to printf. Right. And this should work, I guess. Let's see. First try. What do you think, guys? First try? Okay. Of course not. Oh. Of course. Parser.h. I can't use return in an identifier because that's a keyword. Also, that's not how you do this. Can I do this instead? I don't think so, yeah. Okay. How should I call this? How should I call this? Well, ret for friends. Okay. Where is it? ASTR return. What now? It compiled? Yeah. Oh, right. Why am I not using a switch statement here? Okay. Yeah, I should. Gen return. Oh. Where is? Where is the infinite loop here? What am I doing wrong? Yeah, this isn't called return because that's the token, but it's called return statement. Ah. But still. What do you mean? Oh. Thank you. Thank you. Still, it's... there is something wrong. Time for GDB, I guess. Is it? Well, no, time for printf. What am I saying? Now that I think so. Now that I think about that. Here. Am I consuming as I should? Because I don't think I am. Very professional debugging here. Okay. Okay. Well, I'm consuming the token. So what's going on here? Yeah. Okay, let's say we didn't saw that. Okay? Nobody saw anything. Still. Is it parsing the expression? It is. So this is a code gen problem, I think. Yeah, definitely a code gen problem. Oh, let's see. Let's see. What? What's going on? Are you getting it here at least? Where is the infinite loop? Oh, of course. Yeah, it's not even getting here. It's not getting here. So the loop is in the parser. The loop is in the parser. But it's getting all the way here. And I'm returning. Maybe check. Okay, yeah, that was the issue. That was the issue. I wasn't consuming the semicolon. Let's take a look. Okay, it's generating the return. So now if I compile this, yeah, okay, it works. So now our program is not segmentation faulting anymore. And that's something. That's something. Now, what's next? We have functions. We have the main function. Okay. Have I removed all the printf? Printf. Oh. Where is it? Here. Go away. Okay, so guys, what should I implement next? I think variables, because right now I don't have variables. So let's work on variables. Oh, I have gen definition. What do you mean? What are you defining? Oh, okay. Makes sense. Variable assignment. Okay. AST variable. AST variable. Okay. Yeah, really, I was already doing that here, so this isn't needed. Where is it? This one shouldn't be here. Okay. So I am already parsing that. I just need to generate the code for that. So for variables, for local variables, we need to use the stack. And I think that on x86 the stack goes downwards. x86 stack. Let's see. We have ASP and ABP. Okay. So yeah, we can use the stack. So I need to keep track. Oh, you got malloc and free working? What do you mean? I mean, I can use malloc and free because I have function calls. I'm already using some standard library stuff because I'm using the write system call, which is a Unix standard library function. Yeah, now I have to use the stack to generate local variables and keep track of them. Okay. So here I have definition. Yep. So. How do I store the address of the stack? I'm going to use C, but it has. You don't really. You can define functions inside of structs. What you usually do, which is what other languages do, by the way, you just pass a pointer to the element to the struct you want to work on with a function, and you pass it as the first argument. That's what people usually do. Okay, so now I have to find some way to keep track of local variables. So every time we get into a new scope, I need to track that scope. So I will need some structure for that. Let's see. And in the scope, in the scope here, I will have a base pointer for the stack. So size t stack base stack pointer. What else? Yeah, then I need the offset for the local variables and some way to access the local variables. I can map them in a tree or try, depends on who you ask. So a try. Okay, I will wrap the map the ID to a try, and then I will map the offset from the stack on the try. I think that could work. Yeah, that should work indeed. And I can call the functions only from the scope. Okay, so let's try. So here I'm getting a define, where is it? Variable define. I would do a dynamic array of scopes. Well, really, the scope should work like a stack, in my opinion, because when you call a function, you get into the new scope, so you can push the scope on the previous one. Then when you return, you pop the scope and you get to the previous one. So I think that here it can just be a linked list. I would use a linked list as a stack. Okay, so I have to map this identifier in some way to an offset. I will just order them. So every variable has a type, so I already know the size. And yeah, I can map that. So I think I need to do that previously, before the generation of the scope. You're right. Okay. Okay. Oh god, that's harder than I thought. So the mapping should be done before generating the code itself, because I have to store that in some global. Okay, so I will create a global linked list of statements, of scopes, which are defined here. I will create a global linked list of these. So, yeah, I don't need a doubly linked one. I can just use one, and I will create a global pointer. So static const, static struct scope stack. Okay. So here I need std_def. Okay, I will initialize these here. So scope stack equals to malloc. Okay, and I will free that here while scope stack Okay. Um, mm, 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 mm. So now I can just, I want to create some helper function here. Void push scope. Oops. Okay. And this will just take a new scope. So struct scope. Well, really, I just have two parameters, so why you create temp scope? You just free. Um, because if I free the scope stack, then I cannot set the scope stack to the next one because this pointer will be invalid. So I need to create a temporary one which holds the value of the original one, so then I can set the pointer to the next one, and then I free the temporary one. So I don't invalidate the pointer I'm trying to access, or it will end up in a segmentation fault. Okay. Stack base. And so scope stack next. Okay, and this will push. Now I need to pop. So I get struct scope pop scope. So again, struct scope tp. What distro are you on? I'm on Gen 2. Just normal assign to next. But here, if I... Oh, okay, I see what you mean. So you mean like this? Well, doesn't really change if you mean this, because then I will do free scope stack, and then here I would have to scope stack equals tmp. So it's the same thing, if that's what you meant. Okay. I have one installation. XFS. Never use XFS. I usually use X4. I would like to try B3FS. How do you call that? Yeah, B3FS. Looks cool. Oh well. Yeah, actually I need a doubly linked list. I like ZFS. Is it like B3FS but from Sun? Is that B3FS is from Oracle, if I remember correctly, while ZFS is from Sun? Wait. Isn't now, doesn't Oracle? I think Oracle acquired Sun, so probably I'm wrong. Yeah, I like the snapshotting, but I know also ZFS can do that. I need a doubly linked one. Okay. So here I can just go backwards. Okay, because this will be the last element, the tail, and I don't need to store and head this way. Okay, so this looks correct. Yeah, should be okay. And so here I will here. Okay, so scope stack equals to scope stack previous, then tmp previous equals null. Hello. Mhm. Uh, okay, so my brain is bugging right now. Okay, this should be correct because this is the last one. So I get the previous one and then I just return tmp. This should be correct. Okay. So now I have push, pop, and when I have a block, I should create a new scope. And then I should pop if I have a return statement. Okay. So here I will do end if block value dot statement. What's standard of C99? Statement D equals return statement. Then go to end. Okay. And here, oh well, no. No. Oh, okay. Okay. So yeah, I can't really get out of scope here because if I have a return statement, I will be indeed out of scope, but only if the return statement gets really cold. But I can't interpret the AST. Why don't you use Visual Studio 2022? I don't know what's that. You mean like the Microsoft IDE? I think that's only for Windows. What resource do you use? Well, right now I'm not using any resource really. Right now I'm on myself, struggling to understand how to implement the scope, honestly. Uh, okay, so the scope can't be dropped just by exiting a block, because we also have a return statement, but I can't interpret it. Is it Groovebox team? Yes, it is. I can't run the AST to check if the return statement is really getting called. Hmm. Well, do I really need to do this? Because I don't care about the return statement, because that will just change the stack. But here I'm just generating code, so I don't really care about that. Yeah. So this will push the stack here, the scope here, and it will pop the scope just like that. And so I have a stack base and a stack pointer. The stack pointer will change when I create new variables as I push them on the stack, and then I will pop everything when I am out, when I am out of the function. Okay, that should work. That should work. This is peak software engineering, as you can see. Absolutely not deciding stuff as I'm implementing them. Okay, the pointer, we said that grows where it grows. Hello? Okay, so I will push the base pointer. I have a base pointer here. And I think I have to calculate the size of the stack I need for local variables, and then fill everything and then get to the end. But really I just... Oh, I don't... So is x86 stack growing downwards? Hello, I'm fine, thanks. How are you? I don't really want to know this. Okay, so yeah, I have to calculate the size of the stack I need and just go all the way to the end of the stack. Okay, so that's a bit more complicated, because I think it means that I need to traverse everything twice. Unless... Huh. Can I? do that in the parser, maybe. So when I have the block here, block, okay, I get a statement, so I can just check whether this statement is a variable definition, and if it is, I will check the size of the type of the variable, and I will add that to the block member. Okay, I will do like this. Hello everyone. Okay, so parser.h, and here I have to change the block member struct, which is this one. I also need to store size t stack size. Okay, and here so what is that thing you use to find? It's called telescope. This thing here, telescope and beam. This. Very convenient. It's the reason I'm using NeoVim and not plain Vim, just because NeoVim can have this plugin. Very cool stuff. Okay, so I don't really remember my own code. Why here? Okay, yeah, I'm parsing everything. Oh, because the block, this is, oh, is a linked list of block members. How? Okay. I can... Okay, so here I have a head, so I will just store that in the head. Okay. Yeah, that's what I also return. So size t stack size equals 0. And then here, every time I get a new statement, I will check if statement dot state statement equals how is it? What's the statement type? It's variable definition. Var definition. Then in this case, the stack size will increment by the statement dot I think it's called var def. Yeah, var def, and then it. Okay, I have a type. So type, and I need to get the size of this thing. So here's the type size. And this function doesn't exist, so I have to create that. Ast export type. Okay. Yeah, everything's fine. Thank you. So I have an expression type here, which is what I have to return. Well, what I have to take, and I will return a size t. So size t ast type size, and this will take an expression type. Okay. And here I will have a good old switch statement. And let's see. some Vim magic here. Okay. Then okay. How many times? 10. Okay. This is why I use Vim, by the way, and not VS Code or Visual Studio. I don't know who was saying that Vim is inconvenient. Oh well, I just realized this should be returns, not breaks. Okay. Okay, so this is 1, 2. Oh wait, they are ordered? Oh, but they are not too much. I would have done some more Vim magic. What am I doing here? Okay. This is 8. 1, 2, 4, 8, 4. Well, this doesn't really have a size, and this we don't know. Oh well, I'm not hating on VS Code or other text editors. I'm just saying that someone said that Vim is inconvenient, and I was showing them why for me it's very convenient. Okay. And yeah, this should work. I just have to change this. So, oops, block. Yeah, how was that called? Stack size. Okay. Hmm. Okay, so no need to double traverse twice all the blocks. This is what I call efficiency. Code. So since I already know the size of everything here, I can just set the stack base, to be the next value right after the stack pointer of the previous of the previous um, of the previous scope. Yeah, I think I can just do like that, because the stack, yeah, I can put the stacks one after the other. So first of all, here I will pop the previous scope. Will I? Yes, I will. So pop scope, and then I will push scope, and the base will be previous stack pointer, right? Yeah. Stack pointer plus size of assign PTR. No, how was that called? Oh, U in PTRT. Okay. Friendly that violence. Okay. Vim is violent indeed. Very violent. And the pointer will be, well, let's just say that this is the base. And this will be base plus base plus base plus what? Uh, base plus, well, the stack size, I guess. So block stack size. This should be okay, right? I think it is. So this way, whenever I have a new scope, yeah, I start thinking that this isn't really needed at this point in the code. Because when I enter a new block, I don't necessarily need to set a new scope, do I? Because for example, I have an if statement. I don't really want to have a new scope. So, yeah, this is more something for functions. So, here, this is more something for functions, because when I enter the new function label, then I have to set the stack. Or should I set the stack when I call? What do you think? When I call or when I enter the function? No, I want to do that when I call, because this way I can push the... Oh, hello. So this way I will push on the stack the previous base pointer, like where it is, os dev, no, stack x86 stack, okay, like this. Where is it? Yeah, ABP. Okay, but call will push already. So okay, since call will push on the stack the return address, I will do that in the function here. So right after getting here, I will add an instruction to push the RBP. Oops. Okay. Okay. Oh, guys, by the way, remember to join the Discord server. I have to say that every minute. Oh, today no one joined the Discord server? Really? Come on, guys. It's free. Okay. Then after pushing this, I will create a new stack by setting the base pointer to the next one. Guess what happened? What did happen? Oh, okay, it worked. 2 new members. Welcome, welcome, guys. Thank you. Okay, so yeah, I better remember to join the Discord server every minute. Apparently it works. So should I increment this by the actual size? For example, here is 12 and then 6. Yeah, okay. So I have to consider the byte size. And since the EBP is a pointer, it's 64 bits, so 8 bytes. I have to put the new EBP 8 bytes after the old ASP. Okay, so how do you do that? We need an add instruction. Oh, here I forgot this. We need to add. What do we add? We add 8. Oh, this is in RISC-V, so I need to do something like this. Move 8. I will use... what will I use? Really, I can't have... Oh, this is why I love RISC-V and I hate x86. So I can define a different destination for some. Well, okay, I guess that's okay. So I need to use another register. Can I just use array_x? Well, not really. Not really, because I'm using that thing. I'm using that thing already. So no, I can't. Well, the core registers are just these. So I have, for example, R10. Yeah, I can use R10, I think. So I can do something like this. R10. Hello. Also want to use this because I feel cooler. Okay. And then I can add the RSP into R10, and then after this I can move R10 to the ABP. To make assembly by yourself, I made an assembler. I made an assembler for a custom virtual machine I made some time ago. Well, after I finish the C compiler, of course, I can't use the GNU assembler. I will have to create my own assembler. Hello everyone, I see people are joining. Remember to join the Discord server, by the way. Wait, so you are trying to making a C compiler in C? Yes. And also, where are you from? I'm from Italy. I made a video on this project where I showcased the very basic basic achievement I got. Okay, so here I get all of these, and then uh, okay, so here I will get the size of the stack and move So fprintf f add, and this is a literal, so a number literal, but I want to use hexadecimal because I'm cool, and then um, the destination will be R10. Okay, and then finally I can move R10 again to the stack pointer. Why I'm using the 32-bit one? It's the 64-bit one. Okay. Okay, so this should set the stack correctly, I guess. It should. It will be. It will probably do some weird stuff for the main function though. But we'll see. We'll see. Okay, and oh, also, once we go out of the function, I need to pop the RBP. Okay. Yeah. Okay, so this is NeoVim. I use NeoVim because I like to use telescope, this thing here. Very convenient. Pop. RBP, but before doing this I have to reset the old stack pointer. And so why I wasn't saving the stack pointer here? Because since it grows downwards, I need to also change that. Probably because I should just pop everything. But that's not very convenient. Because here, in this scheme, okay. Okay. Okay, so I see where this is going. You should remake this. I'm writing already enough assembly, I guess. I could create something in assembly maybe at some point, like some, I don't know, arcade game. Uh, maybe using real mode, not really using any fancy graphics library, even though I could use libx11 to open a window in assembly, shouldn't be much hard. But yeah, it would be cool to create some old style DOS games in assembly. That would be something I could do for sure. Anyway, since the stack is growing downwards, oh, wait. Uh, so the parameter is going to higher values, and this goes to lower values. Yeah, that's right. That's correct. Yeah, it would be cool in a window, and yeah, I can get a frame buffer from LabX 11. Yeah, I might do that actually. So okay, next time, I don't know, Pac-Man or Tetris or Snake, maybe Snake in x86 64 assembly for Linux. Hmm. I'm getting confused by this thing here because they could at least put some address numbers. I8 x86. Terrible, terrible one. Terrible architecture. So since here I have the parameter 1 higher, okay, so this is the opposite of how usually memory is represented. Yeah, while local variables are down the stack. Okay, so I have ABP, then I have ASP, ESP, okay. Okay, so I need to subtract. I need to subtract here. Do I? No. Yeah. Yeah, I need to subtract. How much? Well, the stack size, I guess. So the EBP should go to the RSP, right? Yeah. So okay. Do you use Linux or Windows? Uh, I use Linux. I was thinking about that. Yeah, I use Linux. Pick software development. Yeah. Pick x86. Okay, so I need to subtract this. So this is correct. And here, after doing this, I will pop this thing here. So it will go back somewhere in some way. And then the stack pointer will be set to the... Oh. Oh. Yeah, before doing this, I need to set the stack pointer to where it is, where it was. So the stack pointer should be equal to EBP, just like that. So I will pop, and the stack will be restored. If I'm not wrong, so I can just do like this. F, and then I will move the current base pointer to the stack pointer. To the stack pointer -1, I would say. No? No. No. Just like this. Or maybe not. Yeah, I think just like this. Okay. Okay. And so this should be should be just correct function call, except that here I haven't passed the correct size. So this is statement.function.block dot stack size. Okay, let's see what happens. Make what's the problem here? Parser.c line 135. Oh, so this is, yeah, of course it's statement t. Okay, and here this is a pointer. Okay, here I need to include lib. It compiled. Yeah, about this. Did you guys see any error or warning? Honestly, I didn't. No segmentation fault. Are you sure? Are you sure? Well, it did something. I don't think that this will work. Let's see. Okay, that's what I thought. So what's going on here? There is no return? What? Why? Like, all I'm missing is this? Really? No, okay. Not only that. Well, time for some debugging, I guess. So valgrind out. Oh, ah, maybe I should at least generate some debugging symbol. What now? Okay. And yeah, this tells me absolutely nothing. Uh, let's see. To line. Oh, are you for real? I mean, why? What's wrong? Okay, well, time for GDB then. Okay. So, layout ASM. Well, break main. Run. Okay, so let's see what's going on here. We have RSP. How is the Moonlander? Oh, it's fantastic, but right now I'm not using it because I have to get used to the Colomac layout. So I went from like 90 words per minute to 30, and I can't really do any programming with 30 words per minute. So I need to get used to the Moonlander. But yeah, absolutely, it's fantastic. I flashed a new firmware with QMK. First time I ever did something like that because I've been using this same keyboard for the last, well, 9 years or so. And of course, flashing firmwares wasn't really a thing back then, at least not that I did know. And so, yeah, it was pretty cool. Very nice keyboard, by the way. Okay, so no problem here. Okay. So where are the problems? Here? No? Okay. No problem here. No problem here. Okay, still no problem. And so, where is the problem? Okay, here I'm moving the stack pointer. Okay, and I'm popping the base pointer. Okay, that was the issue. Okay, so let's try working directly on the assembly this time. Okay, so yeah, this doesn't mean anything, so let's at least move this stuff around. This should be after all of this, right? Okay, so let's see what's going on here. So I'm pushing the base pointer, and then I'm adding 8 to the stack pointer. Right, to do the last instruction. Oh, really? So you are telling me that I've been using GDB for the last 3 years without knowing I could just do that? Okay, that's nice to know. So here I'm adding 8 to the stack pointer, and then I'm moving the stack pointer to the base pointer after pushing the base pointer. Well, this doesn't look weird. It looks correct for me. And then here, well, basically I'm doing the same thing. Am I? I should subtract 8, I think, from the base pointer. So, sub. What about that? Oh, okay. No segmentation fault. Okay. That was the issue apparently. Very easy. So here I need to add subtraction of 8 to the RSP. Okay. So let's see now. Oh, why? Oh, I know why. The return statement. Okay. Yeah, so why is my return statement getting where it shouldn't be? Where is my return statement? Gen return. Oh well. I know why. What now? Oh. Oh well, yeah, that makes sense. Hmm. What sector do you work? Oh, I I'm in high school. Are you using Linux or Windows? I'm using Linux. Can you like make Windows look like this now? And I don't know because a lot of people are asking me. I mean, this looks very, very Linux to me. Uh, okay, so I should do this thing when I'm returning, not when I'm just exiting the function itself. Because anyway, even if I don't have any return function, I should return anyway if it's a void function. Okay. Oh, okay, yeah, you're right, you could do that. But I have the DWM bar here on the top. Oh, thank you. You can run DWM on Windows? Really? I haven't used Windows in years now, so I don't really know. I will just move this part here, right here. Let's see. Oh, but if I have a local variable, oh well. Oh, I can just assign the value before changing the stack and then returning. Let's see now what happens. Perfect. Will this actually work? Let's see. And what's the return value? 3. Perfect. Okay. We got the stack working. Nice. Are you guys joining the Discord server, by the way? Yes, you are. Thank you, guys. Thank you, guys. I keep it around only for League of Legends. Okay. Yeah, mm, I've never been uh, a big gamer. I mean, I literally just play 2 or 3 games, and I've been playing 2 or 3 games for most of my life, which were when I was younger. I played a lot of GTA 5, and I played Minecraft for most of my life, and that's what basically uh, made me into programming. And then I really like Half-Life, and now I play some open source games like this one here, Xenotic. Oh, okay, very high, very high volume. Sorry. This is very cool, very, very cool. I will organize some matches maybe with the guys on the Discord server someday. uh, sorry. Uh, sorry. Yeah, I didn't remember it as that much of an high music. Okay, so now we have the stack, so I can finally define local functions with the stack. Okay, so each definition should just so need I need to keep track of where the stack is right now. I need to keep track of my own stack pointer basically. Or can I use the stack pointer from the CPU? Well, I should be able to do that. I mean, I can store the variables as an offset to the base pointer, just like that. But still I need to keep track. So like I'm doing here, I can just static size t base offset. And when I finish parsing a new function, I will reset this to 0. Just like that. Because then, for example here, if it was local variable 1, I pass 0. Oh, this should be negative. Well, I can just subtract this as if it was negative. Okay, cool. Cool. I like this. Shouldn't be much hard. And so I need a try, but I don't remember the API I made for the try. So, okay, try insert, try get, very easy. And how do I create a new one? Okay, just like this. So this will be variables. And well, let's create a pointer out of this, because I want a new one. I have joined your Discord server. Thank you. Thank you very much. It will be easy when I start a new live if I have you guys on the Discord server. Wow, we are a lot now. Thank you guys. Okay, so I want to create a new one every time I join to a new function. And then I will insert this stuff here. Okay, so generate function. Here I need to allocate a new try. So, oh, how have I called it? Where is it? Try variables. Okay, makes sense. So here I have variables is equal to struct 3 malloc size of struct 3. Okay, and here I free variables. Very easy. Okay, so every time I define a new local variable, I will insert the identifier of the local variable into the try, giving as the integer an offset, which will be defined by this variable here to the stack base pointer, which will then get subtracted to get the actual value. I think it should work. I hope it will work at least. Okay, so let's do that. Here, okay, so try insert variables, and this will be the identifier. So how is that defined here in the definition? It's just an identifier. Okay, so we have statement variable definition dot identifier, and then I will have the base offset. Okay, and after I do this, I will increment the base offset by the size of the type. Do I know the type? What? Oh yeah, okay, of course I do. So base offset will be incremented by oh, hello everyone. We are a lot now in live. Remember to join the Discord server, by the way. Okay, so I had the function here that, yeah, AST type size. Just I can do just AST type size, and the type will be the statement var definition type. Okay. And well, here I don't really have to do much else because I'm not assigning any value to this. So I don't really need to set anything, but I do need to do that in an assignment. I do need in an assignment. So here I could have an assignment directly in this thing here, or I could have that separately. Your logic. Oh, thank you. Thank you very much. Okay. Yeah, I will check if there is any assignment already here. Statement var definition assignment. If it's not null, I will generate an assignment. Oh well. Wait, no. Oh. Okay, I'm trying not to be too much verbose, but I think I will leave this way so far. For now, at least. Okay, so now I can create a new function, which is generate assignment, which will take file and AST statement T assignment. Okay, and what this will do is to take the identifier. Where is it? The identifier. Check the offset. Check the offset. Okay, and then move the value here to some register, and then I will set the memory tied to that offset from the base pointer to the value containing that register. So here I have generate generate move. Okay, this is what I need. Okay, so why I always I always lose my functions. Okay, so I will generate a move. Generate move in this file, and the value will be the assignment. Oops. Statement var assign value into the R10 register, maybe. Yeah, R10 register. Okay, and then I need to try get, right? Try, yeah. Oh, what will it return? Try. Okay, it's an integer. So fprintf f, and here I need to have the move. So move the R10 register into the memory region. So X, and this will be our base pointer, and the offset will be try get variables, and then I have the assignment statement for assign identifier, just like this. It should work like a charm. What do you guys think? Will it work? Maybe not first try. Okay. Okay. So now I also have generate assignment. I think I need to also add this here. Generate definition and generate assignment. Okay. And here I should also check for the assignment. So generate assignment F statement. Okay. Well, let's see what happens now. So a definition would be something like this. For example, int x equals 3. Yeah. Also, I need this thing here. What happens now? Make. Oh. Oh well, yeah. So where is it? Where is it? Here I don't need to put this thing here, and not even here, somewhere else. Try put, no, try insert. Okay, here I don't need the pointer thing. What else? Gen oh, how is it called? Gen mov? And what's the problem with that? Well, the problem is that it's not here. That's the problem. It is a problem indeed. Okay, it compiled. No segmentation fault, and that's something. Let's see the output. Yeah, I don't really see the variable anywhere. Oh, right, I've not assigned it. No, I did indeed assign it. So what's going on here? Huh. Okay. Is it at least going here? Yeah. Okay. So the problem probably lies in the parser. Variable. Okay. Yeah. variable statement variable definition dot assignment. What about this? Oh, well. Okay. Oh, now I see something. Okay. What happens if I compile this? Assembly segmentation fault. Okay. Segmentation fault. Why is that? Why is that? So here I have an integer. So stack pointer should go up by 4. And indeed here, generate function, I have this part here when I add the size to the R10. And I think it's this part. Let's see. R10, RBP. Yeah, it's here. 4 bytes. It's correct. The size of an integer is 4 bytes. And then I move this just like that, and I have the move here. Okay, so what's causing the segmentation fault? Let's compile with debugging symbols. Okay. Oh. Okay. Hello. Welcome back. Okay, so yeah, it does print 2 times, so probably the problem lies around here, maybe? No? Then here? No. So the problem lies here? Not even that? Then the return? Why? Why is that? What's going on? In what case the return instructions can cause a segmentation fault? I mean, what happens? So is this a problem also if I don't have an assignment? What if I comment this out? Okay. Here I don't add anything. And so GCC. Okay, I think I know what's wrong here. Because here I'm adding this, but then I'm not subtracting here. And probably I should. So size t stack size equals 0. And then here I will stack size equals, okay, stack size, and here I will just stack size plus 8. Let's see what happens now. Oh, yeah. And the size. Stack size. Oh, yeah, right. Oh, okay. This is another thing here. How do I get this stack size? I could set that globally. Let's use global variables. Okay. And so here I set it to 0 here. Stack DWM, yes. See magic. Yeah, see magic. Can your Rust do this? I don't think it can. So now it's subtract. Yeah, maybe 0x. Okay. Okay. No, what's going on? Ah, yeah. No. What are you doing here, man? Oops. Better now. So please, GCC, do some magic here. Oh, really? Oh, okay. That's sad. Why is not working? Oh, hello guys. Remember to join the Discord server. Yeah, this is disappointing. Well, isn't this an issue? What's the output here? Do I have some weird 10? No. Okay. Okay, that's cool. So here I am adding correctly the stack size, right? Yeah. Okay. What about this? Yeah, still segmentation fault. Hello. Hello. Good evening. Well, good night for me. Yeah, this should be indeed +8, but still. Let's see the output. Oh, I can't understand anything like this. So this is where the stack stuff ends. Then there is this calls, and this is where the call stuff ends, and this is the stack again. Okay. Well, I also have some stack stuff here because here I have the variable definition and assignment. Okay, so here what I'm doing is first of all I am moving 8. Okay, because it's the size of this thing here. But really, since I'm already pushing this, do I need to also do that? Hmm. I'm not sure. Really. I'm not sure. Bus error, okay. 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 I was joking. Of course. Um, Because here I'm setting these to be 8 plus the base pointer, and then I add 4, which is the size of my variables, and then I do RSP. Oh, first of all, I just realized that this should be, where is it? Somewhere here. Yeah, here, this should be minus. Okay. And yeah, so this should be correct. This should be correct indeed. And so we have R10, RSP, okay. Then here I move to the base pointer, which is correct. At least I think it is correct. Then we do all of this stuff and then go back here and I move the RSP to the base pointer. Oh, wait. Still segmentation fault. Okay. So I have to do this the other way around. So first of all, I added 4 to the RBP. But really, if I'm setting directly the RSP back to RBP, then this thing gets skipped. Okay. And then by subtracting 8, I am indeed going back here to the RSP. To the correct RSP. Yep. And so when I pop, there shouldn't be any problem at all. But is this part here really needed? Like, is it really needed? Yeah, I get a bus error. Okay, so this is assembly magic. I wanted to see, let's copy GCC. Should we? Should we? Oh, look how nice this is. Let's check for the main function. How do you call that? I think main, maybe? Yeah, okay. So here it's pushing the RBP, then it's moving the RSP to RBP, and then it's subtracting 20 to the RSP, but it's 20. Let's see. So the arguments should be an integer and a pointer, so 16 bytes. No, 16 is 10. Why is bubble? Oh, probably local variables. Okay, makes sense. I made a simple Python sh frontend for Linux. You mean like a shell? Okay, so this is interesting because it's not what I am doing. and it's subtracting 20 to the RSP. Okay. Okay. And then it does nothing to the stack. Doesn't. Oh, because there is also the. Yeah. There is the start function of the C runtime. Let's see more about here. So this is a very big number. It's adding, okay, so it's doing some magic. And then what about if we go to the end of this? Oh wow, a lot of code for the lexer. Very big lexer. Let's just search for it. Okay. Oops. Okay. So RIP, RIX. It looks like it's not doing anything at all to the stack, but that's not possible. How is that possible? What does the leave instruction do? Leave instruction. I never heard about that. Leave. Oh. Okay. Okay. Well, this is this is very good because then I basically don't need all of these. I can just subtract the size of the local variables here, and then here I don't care about any of these. I just leave, and here I move RPP to RSP. Is this legit? No, okay. Okay, see? GCC is wrong. GCC is wrong. What's going on here? Okay. Yeah, but really, why subtracting though? Why subtracting? Expression. Let's see. So, yeah, it is subtracting. Okay. 10. 10 is... Okay, so they are the local variables. And what does this instruction do? I don't know this instruction. No, wrong part. And beer. What is this? Okay. Oh, I did the other way around, I think. Yeah. Okay. Problem solved. Oh, I am. I'm a big fan of Mr. Azuzin. A very big fan of him. I can imagine doing this for fun. Oh, Creating compilers is fun. It's funny. Come on. Okay, so here I can just get rid of all of these, like all of these, and just push that, and then move RSP RPP. This is not needed. Not even this. I can just RSP. Would you ever write a text editor or any editor? I tried creating an editor some time ago, like 4 years ago maybe, in Rust, and yeah, usually I tend to write stuff that I would actually use, but since I don't think I'm missing anything from Vim, I don't think I would ever need a new editor. I mean, Vim does anything I need. Okay. And so here, instead of all of this stuff, I can just leave like this. And that's okay. That's all. So really, I don't need all of this stuff. I can just revert back to when it was simpler. Okay. And also this global variable here is not needed anymore. Let's see. Make, oh. Yeah. Okay. Okay. Oops. Oops. I can just... Okay. Yeah. Let's see. And no more segmentation fault. Okay. This is cool. Now we can assign variables, local variables, the call frame. But now I want to print something from those variables. Should we? Yeah, I think we should. So what if instead of a number, I create a local variable containing a string? So here, for example, instead of doing this, I want x to be equal to oh, please, 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 Vim, please. Okay. Hi chat. And then backslash n. Okay, make okay, why rstr0? So the parser for the string literals is definitely not working as it should. It's definitely not working as it should. So parser.c literals. Am I incrementing a str count somewhere? Because it doesn't seem so. But I might have done that somewhere else. A str2. Oh well, okay. Yeah, I think I'm not constructing the head anywhere. What did I have in mind when I wrote this code? This is a mess. This is a mess. Okay. So what I'm doing here exam label str count. I should indeed increment this, but then the list should go on. Like so. This is the case only if literals had. I was probably very tired, because when I'm tired, I tend to do this kind of stuff. Okay, and then of course literals needs to be equals to literals next. This is a linked list. Oh. Okay. Oh, still. We got the first one, but not the others. What am I using here? I have indeed the literals head. Well, I can just... Why am I adding new nodes like this? So, what even literals is? Why do I need this thing here? I don't. I just need the head, and then I will allocate a new one each time I get a new string. So literal pair literal. Okay. And then assign like this. Literal next equal literals head. And then literals head equals to literal. What about this? Whoops. Oh. Yeah, that's inconvenient. Well, of course. Of course. Well, no, not really. What's going on here? I have an infinite loop somewhere. So if it's null, then we create a new one, which is this thing here. And the next one, okay. Well, else. Okay. And really this is the case anyway, so I don't really care. Okay. Oh, finally, we have all our string literals. Fine. So here I have str1, which is not correct. Very good. I would expect str0. I would expect str0. Why is that? Oh, because I'm incrementing before. Okay. Now it's correct. Let's compile this thing. Please, okay. And nothing changes, of course, but now, here, I want to be able to also use that thing here. So in case the expression is an identifier, so expression type equals to identifier, but how's that called? Parser.h. It's called, oh really, I don't, oh ID, okay. If it is an ID, if it is an ID, then I will need to get the variable offset from that. So I need to fprintf, and this will be a move from an offset, so 0x of the variable to the register, and this will be expression.identifier register. Oh well, no, not this, but it will be try get variables, okay, and the key will be the expression identifier, okay, and this really should work, I think. So what if now, for example, what's going on? Okay, what if, for example, here instead of putting the string literal directly, I just put x like this? What happens in this case? Okay, okay. So here I set the variable, and that's okay. But then, oh, okay. RBP, this is a minus. Okay, so I'm putting that thing in RSI. It looks correct. Let's try. Guys, I'm so happy if this will work. Oh, wow. Wow. Okay. Okay, that was first try actually, basically. What if I have more than one? So I also have hi Discord. And then the second one will also print a variable which will be a. Well, it's not 13 characters. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 characters. 10 here, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's correct. Okay, so let's try. Okay. Oh. Okay. Okay. Let's see the assembly output. So I have two calls to write. This is 0. This is 4. 4 looks quite right. And RDX is 10. RDI, RSI, RDX. Yeah, it should be correct. It should be correct. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And this is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes. So why it's not printing the first one? But it is printing indeed the second one. Here I'm moving stuff correctly. Am I? Steer 0. Yep. Steer 1. Okay. So what else? This does seem correct indeed. Why it's only printing the second one? Yeah. Nothing really changes. 0 RDI. So for some reason it doesn't really like the first string. But it's okay with the other one. But it's always printing just once. What if I just call the same function twice? Okay, in this case it does. It does indeed. And what if I change this to be the other one? Okay, so the problem is that when I have two variables, one gets the right value and the other one doesn't? What? What's going on here? Are values getting over with? Oh? Uh, no, that's not possible. That's not possible. Could this thing here be a problem? Also, could this thing be a problem? Um, because if I change this, wait. So in this case, okay. But if I change this to be the first string, I get the second one, okay. Oh, okay, this is hard to troubleshoot. For some reason it's overriding stuff. It's overriding stuff. What about putting this in the opposite order? So, for example, 0 and 1. It prints the second one, so yeah, looks like they are getting overwritten. So is the offset really working or isn't? Maybe the syntax of the offset is wrong. ATNT assembly syntax offset. please. Okay. Yeah, this looks like something legit. Move 4 bytes. Memory address. ASI. So could this be something with the size of this stuff here? Oh, wait. Wait. I'm storing the strings. I'm storing the strings as an integer, which is 4 bytes instead. They are 8 bytes because are pointers, of course. They are pointers. Wow. Okay. Also, why is this 4? Should be 10, I think. And indeed it works now. Okay. So the problem is that here I was using the wrong type. And this is what happens when you have no static type checking. So okay. Still, I don't like this. It should be 16, not 8. What's going on here? So in the generation of the function, you have the stack size. Okay, but the stack size is defined in the parser. Is this correct? So I have in 64 it's 8 indeed. And here, okay. The stack size which is 0, and then for each statement I check for a variable definition. Oh, but there are also assignments. No, that's not the problem. Yeah, it's about definitions. So if it's about definitions, this should just work indeed. It should just work. But of course I'm getting only the first one because of this thing here. Because of this thing here. So what if, since I have the head already, I can just increment all of these, and then I will set these to the head at the end, so that I will have head, okay, like this. Let's see, okay, and now it's correct. It's using 16, 10 in hexadecimal. And then I can compile this assembly output, and yeah, we have local variables, guys. So this is the code I'm compiling. I'm using long integers because I don't have pointers yet. So to store a pointer, I use just a 64-bit integer, which is the same thing. So I have a variable to which I assign a string literal. Well, two variables to which I assign two different string literals, and then I have two functions which are Unix standard library functions. The write function, which is a more primitive print, basically, and I print to the standard output, which is 0 as the file descriptor, the two variables, which is x and a, and then the length of the two strings, 10 and 13. And then I return 3. Does it return actually 3? It does return 3, indeed. And so today we implemented the return statement for functions, the stack frame for functions, and local variables. That's all we did in just 3 hours. Okay, have you guys joined the Discord server? Yeah, I see a lot of people joined. Thank you guys. Thank you very much. Okay, so thank you also for having stayed with me until now. And now it's finally time to go to sleep, for me at least, because it's 1 a.m. in the morning. And yeah, I hope you enjoyed watching me writing a compiler. And I will ask on Discord too, but if you want me to continue on this instead of Explorer, just tell me and I can do like both at different times. For example, I do today I did the compiler, so maybe tomorrow I will work on Explorer and then the compiler and so on. Well, it's all for today, and so I hope to see you tomorrow. And yeah, join the Discord server, guys. Good night.